See, the question is in a room of five people. So in a room there are five persons. Suppose the persons are A, B, C, D, and E. What is the probability that at least two share the same birthday? Right. So first of all, do you know the concept of at least? Right. So if we have to calculate probability of at least one, if you want to find at least one, so we should do 1 minus probability of none. See, this is not linked with this question. I am telling you in general concept, first of all. Do you know this concept or not? For example, if I am saying that you have rolled, suppose, two dice, right? Suppose we have rolled a pair of dice and we are finding the probability of getting at least 1 6. We are finding the probability of getting at least 1 6. How we can solve this? So the first way you can do, or wait, we can see another example. Suppose we have tossed two coins, right? Suppose we have tossed two coins or three coins. Suppose we have tossed three coins. So first of all, my sample space should be, let me write, head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. And we have to find the probability of at least one head. We have to find the probability of at least one head. Can you think? Can you calculate the probability of getting at least one head?
You said, so that's the so it's one minus the probability of not getting it.
Yes. If you solve directly that probability of one head, so you have to count little more. See, this will be included, this will be included, this will included. So you have to count these many things. So you can write 7 upon 8, right? Total cases are 8. If you apply your concept that probability of at least one head can be calculated as
Wait.
1
I'll
minus,
give it 7 on 8 again because
see, there are the
there's
7 case, one, two,
yeah, you
three.
said at least one head. Okay, yeah.
So at least one head, these all sevens are considered in my at least one case. At least one means either one, two, or three, right? So at least one head should be one minus probability of none of head. So if you see none of head case is only one. There is only one case. So it can be 1 minus 1 over 8, which can be same as 7 over 8. So have you understood the concept of at least, right? Now, for the birthday, we have to find at least two share the same birthday. See, this is the birthday case, and for the equality of two birthday, it means at least two is the minimum case. At least two is the minimum case. You cannot say that at least one person have the same birthday. How you can say the same birthday for one person? So at least two will be here the minimum case, right? So if we say that I can find this probability that at least two share same birthday can be calculated as, or it will be easy to calculate the 1 minus probability of none of them share the same birthday. None of them share same birthday. It means all the five persons should have different birthday, isn't it? If you subtract this case that all the five person have different birthday, if you remove this part, So obviously, in the remaining part, either two will have the same birthday, it may be the three will have the same birthday, it may be have the four persons will have the same birthday, or all the five will have the same birthday. So in place of counting these cases, like two will have the same birthday, three will have the same birthday, the case of four will have the same birthday, the case of five will have the same birthday, we are just calculating that no one have the same birthday. Are you getting this first advantage?
Okay.
So it should be 1 minus. Now suppose the A we are considering the first person A. It will have any one day as his birthday. It cannot have two birthdays, right? So it will have only one day as a birthday. So how many see it can have 365 days. Any one day it can take. So 365 upon 365, right? So this is the case for the probability of person A. It can have any day in a year as a birthday. I have no problem. But for the B, see, out of these 365 days, one day will be consumed by A. So that will be not allowed for my B.
Can you explain this again? Wait, I don't understand.
See, for the A, right? For the A, in a year, all the 365 days are open for him to get birth, right?
Yeah.
But for the B, I don't have 365 for B. I have only 364 days for B. Why? Because I am considering that all should have the different birthday. So see, out of these 365 day, one day will be consumed by the A. On particular day, on any one day, A will get birth, right? So that day will not available for B to getting birth, isn't it? Yes.
Yeah.
Now, for the C, again, one day will be reduced. For the C, it should be 363 upon 365. Are you getting my point? If I'm saying that you all have to get birth on different days. So for the C, it will have only 363 options. For the D, it should be 362 days to get birth as option. For the E, it should have 361 upon 365 days as option. Isn't it? Are you getting this or not?
Yeah.
And you want all these events occurs simultaneously. You don't have the option that okay, A gets birth and B not get birth. You don't have the option. You have to give birth to all of these five friends. So obviously we have to multiply all of them, isn't it? So the probability of none of them have the same birthday should be 365 upon 365. This is for A. For the next one, it should be 364 upon 365. The next one, it should be 363 upon 365. Similarly, it should be 362 upon 365. And the last, it should be 361 upon 365. Just calculate this, you will get your answer. Yeah, have you understood it or not?
Okay. Wait just 1 sec.